Alright, so now I'm going to do part I of 8.4.7. So we have the infinite series of -1 to the k plus 1 over the square root of k plus 1. So this is an alternating series because we have this -1 here at the top that keeps flipping sign for each term. So it makes one term positive, then the next term negative, and so on and so forth. So to see if this series is going to converge or diverge, we can use the alternating series test. So our a sub k here, the positive part, which is not affected by like the -1, is just 1 over root k plus 1. So the sequence a sub k decreases, and it also goes to 0 as k approaches infinity. So we know that the series is going to converge. But now we should find out if it's going to converge conditionally or absolutely. In other words, we're going to see if a sub k, that series, if it can converge all by itself, which would make it absolute convergence, or if it relies on this flip-flopping to converge. So we can compare our 1 over root k plus 1 with a similar series, which we know how it behaves, of 1 over root k. So we can use the limit comparison test. So we're going to take the limit as k approaches infinity of 1 over k plus 1 to the 1/2 over 1 over k to the 1/2. So then we get the limit as k approaches infinity of k to the 1/2 over k plus 1 to the 1/2. This is super similar because the only difference is this 1 here, and as k approaches infinity, it doesn't really matter at all. So essentially, we're just seeing what the limit of k to the 1/2 over k to the 1/2 is, which is just going to approach 1. So since 1 is a positive finite number, we know that the series a sub k behaves like 1 over root k. And we know that 1 over root k diverges because of the p-test, since 1/2 is less than 1. So that means that our alternating series here is going to converge conditionally. In other words, our a sub k relies on this -1 to the k plus 1 to actually converge. All right, so that's it.